A sequence AN has first term A1 equal 1, and subsequent terms defined by AN plus 1 equals LAN for n greater than or equal to 1. What is the product of the first 15 terms of the sequence? Okay, this shouldn't be terribly difficult to figure out. We have A1 is equal to 1, AN plus 1 is equal to LAN. I really don't like don't use the letter L as a variable in mathematics. It looks too much like a 1. So we want the product. K goes from 1 to 5 of AK. I mean, if I want, I can write this as A1 times A2 times A3 times A4 times A5. And I think the best way to figure this out is actually to just solve this entire recursion here. This tells us that AN is equal to L to the power of n minus 1. That should be essentially obvious, right? If I let n be equal to 1, then that's 0, so this whole thing becomes a 1, and that's satisfied. And in going from one term to the next, we just keep multiplying by L, so the exponent should increase by 1. And what I can do now, I can write this as, well, let me use the product notation. Again, K goes from 1 to 5. AK is equal to L to the power of K minus 1. And this is the same as L to the sum, K going from 1 to 5 of K minus 1. So that's L to the power of the sum, K going 1 to 5 of K, put that in parentheses, minus 5. And what is the sum of the first 5 integers? It's 15, right? So this should be L to the power of 10. Is that one of the answers? It's not. Uh-oh, sorry. What is the product of the first 15 terms of the sequence? Not 5, 15. So that's a 1. Okay, so yeah, using the product notation is going to be a lot more convenient here. 15 minus 15. Okay, the sum of the first 15 integers. Okay, well that's 16 divided by 2 times 15. So that's the sum K equals 1 to 15 of K is equal to that, which is 8 times 15, which is 4 times 30, which is 120. Okay, so the whole thing, we have L to the power of 120 minus 15, which is L to the 105. And that is one of the options, I believe. Yeah, so it's option D. Yeah, I mean, if this number were smaller, like I originally thought, 5, then just explicitly computing it like this probably would have been pretty straightforward. But I prefer to do things typically in more generality, which paid off here because this number is bigger. I don't know why I thought it was a 5 there instead of a 15. Yeah, so we have the product of the first 15 terms, which look like this. Of course, in going from this line to the next, I've just used some exponent laws. When you multiply numbers together, you add the exponents like this. And then it's a question of computing exactly the closed form of this. So yeah, nothing too difficult here, just sort of managing all the expressions together. And of course, making sure that you don't make any mistakes. So that's it. Thanks for watching.